In this video, we will be looking at the process of doing a simple linear regression. Press pause to copy the 3 steps in your notes. When you're ready to continue, press play. For these problems, we will already have our data points plotted and a line of best fit drawn. For example, let's look at this problem. The data points in the table below came from an experiment that involved carbon, which they'll use C for carbon, and salt, they'll use S for salt. Note that in the graph, the horizontal and vertical scales are different. This is important for you to notice because you won't be going up one and right one like we would if the scales were equal. The position of the line that best fits the data points is estimated, and that would be this line that's drawn right here. Write the equation that expresses salt as a function of carbon. So when we write this sentence, we want salt as a function of carbon. That means salt is our dependent variable. So it is written where we normally would have a y. And then carbon is our independent variable. So it's written where we normally would see x. So this equation right here is our y equal mx plus b. But we're using different variables instead of x and y. We're using c for the independent variable x, and we're using s for the dependent variable y. Okay. Now our first step that you copied down was to pick 2 points on the line of best fit. To get the most accurate equation, we want to pick our points as far away from each other as possible, and we'd like for them to be on corners of these little boxes. So I'm going to pick this point, and then this point. I'm going to assume this point is on the corner there, even though it's just a little bit off, but that'll be fine. Because this line obviously is not hitting every single point of the data, so it is going to be an approximation. Alright, so we picked our 2 points. We want to write the coordinates of those points down so that we can use them for step 2. So this point has x coordinate of 160. And a y coordinate of 10. This point has an x coordinate of 40 and a y coordinate of 0. Now notice I'm calling them x and y coordinates. We pick the points and we treat this as a mathematics problem. And then not until the very last step, step 3, do we worry about the fact that it's carbon and salt. Okay, so we're just going to be doing this as a regular math problem. Alright, we have our coordinates of our 2 points. Now we want to use those 2 points to get the equation of the line. The first thing we want to do is find the slope. And we find the slope by taking the change in y. So 10 subtract 0 over the change in x, which is 160 subtract 40. So my slope is 10 divided by 120, or simplified 112. Once we have our slope, then we can use the point-slope form of the equation to get the equation. That point slope form is y minus y1 equals m times x minus x1. So I have y minus, and we can use either of these points. Let's use this one since it has a 0 in it. So y minus this y coordinate equals m times x minus the corresponding x coordinate. We'll simplify this equation. Y equals, distribute our 1/12, so 1/12 x minus 40 over 12 is the same as 10 over 3. Then we want to rewrite this, step 3, using these variables. So instead of y, I'm going to write s equals, my m is 1/12. Instead of x, I'll write c, and then minus my b, which is 10/3. Now this is one way to write the answer, but as I said before, this is an approximate equation for our data points. So we could use the decimal equivalences. So I could write 1/12 is approximately 0.083, and 10/3 is approximately 3.33. So it makes sense that since our data, this line is an approximation of best fit, that we would use approximate values for these numbers instead of this. These numbers indicate a lot of accuracy, and we don't have a lot of accuracy with this.